In previous videos, we have talked about variable frequency drives, or VFD, and soft starters. If you need a refresher on the detailed workings of either a VFD or soft starter, be sure to look back at those videos. The devices are similar in that they control the starting and stopping of industrial motors, but have different characteristics that we will identify in this video. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new RealPars videos. This way, you never miss another one. A soft starter is generally used in applications where there is a large inrush of current that could damage a motor, while a VFD controls and can vary the speed of a motor. In this video, we will look at the internal workings of the devices, how to determine which device you might want, and look at some applications to better understand these differences. Let's first talk about the internal workings of the two devices. A typical three-phase soft starter uses 6 thyristors or silicone-controlled rectifiers, oriented in an anti-parallel configuration to start the electric motors smoothly. A thyristor is made up of 3 parts: a logic gate, a cathode, and anode. When an internal pulse is applied to the gate, it allows current to flow from anode to cathode, which then sends current out to our motor. When the internal pulses do not apply to the gate, the SCRs are in the off state, and therefore they restrict the current to the motor. These internal pulses limit the applied voltage to the motor, slowing down inrush current. The pulses are sent based on ramp time, so the current will be slowly applied to the motor. The motor, attached to the soft starter, will start up at a nice smooth current and top out at the preset maximum speed. The motor will stay at that speed until we stop the motor, where the soft starter will ramp down the motor in a very similar way as the ramp up. VFDs have 3 main components: a rectifier, a filter, and an inverter. The rectifier acts like diodes, taking the incoming AC voltage and changes it to DC voltage. Next, the filter uses capacitors to clean the DC voltage, making it a smoother incoming power. Finally, the inverter uses transistors to convert the DC voltage and sends the motor a frequency in hertz. This frequency drives the motor to a specific RPM. We can set the ramp up and down times, just like in a soft starter. From what we just covered, we can see that a VFD is basically a soft starter with speed control. So how do we know which device is needed for our application? The decision on which device you choose comes down to how much control your application requires. If your application requires a large inrush of current, but does not require speed control, then a soft starter is the best option. If speed control is required, then a VFD is a must. Also, the price can be a determining factor in a lot of real-world applications. Since a soft starter has fewer control features, the price is lower than a VFD. And finally, if the size of our device is a determining factor, soft starters are generally smaller than most of the VFDs. Let's look at some real-world applications to help us see the difference between a VFD and a soft starter. The first application will be a wastewater pump. A water treatment plant typically has a constant flow of water coming into the plant. Let's assume the demand for water exiting the plant is constant with the supply entering the plant. Which device would be the best option? That's right, a soft starter would be a great choice, because in this application, when starting the water pump, there would be a large inrush of current on our motor that our soft starter could handle and gradually ramp up the pump. Since the demand for water exiting the plant is the same as supply into the plant, the speed of our pump would not vary. However, If the demand for water exiting the plant raises or lowers, we would want to vary our speed, making a VFD a better choice for the application. The next application we will look at is a cooling fan. In this scenario, a cooling fan will turn on when the plant air temperature hits a high temperature set point. Once the set point is reached, the cooling fan will slow down to maintain the air temperature unless it drops below a low temperature set point, where it will shut off. However, if the temperature continues to rise and pass the high temperature set point, the fan will need to move faster. Which device would work best in this situation? That's right, a VFD would be better than a soft starter, because the speed of the fan will need to vary. If our scenario was only turning the fan on or off based on temperature and not changing the speed, then a soft starter would be a better option. In closing, a VFD and a soft starter can do similar functions when it comes to ramp up or down a motor. The main difference between the two is a VFD can vary the speed of a motor, while a soft starter only controls the starting and stopping of that motor. When faced with an application, price and size are in the favor of a soft starter. A VFD is the better choice if speed control is required. The good news is that if an existing application has a soft starter in place and speed control is later determined to be a requirement, a VFD can easily replace a soft starter. The opposite is true as well. A soft starter can replace a VFD. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.